All right, now I'm going to do a video that covers how to find the second derivative. All right, first, the second derivative of a function is really nothing more than the derivative of the first derivative, okay? So we know the first derivative is associated with the slope of a tangent line. We also know it gives us the instantaneous rate of change, okay? That's the same as like the velocity at a particular spot in time. And then the second derivative is actually associated with acceleration, okay? So on problem number 98, this is really not a product or a quotient rule problem. It just has to do with second derivative, okay? So if I'm trying to find, let me get a red pen. So if I'm trying to find the second derivative, I'm going to do the first derivative of this, and it's just a polynomial, so it's like we've been doing before. 4 times 5 is 20, x to the 5 minus 1, so that would be x to the 4th. Then I'd bring the 3 down in front, multiply it by the 2, get minus 6, x squared. Bring the 2 down, get a 10, and that would be x to the 1st. And that's the first derivative, okay? So the second derivative would just be the derivative of that. So we do 4 times 20, which is 80. Take 1 away from the exponent, get x to the 3rd. 2 times 6 is 12, so we'd have minus 12, x to the 1st, and then plus 10. So this one asks for the second derivative. So you do the first derivative, and then you do the derivative of that, okay? Now that one was pretty nice and easy because the function was a polynomial. All right, this one is going to be way messier. All right, I'm going to change this location. Let me copy that and get it on its own page. So let me move that to the left. Okay, and then let's get it onto its own page. All right, let me scroll that down. All right, and I'll get more space if I need it. I know I'm going to need a lot of space here because this one has a function of x on the top and bottom, and the denominator is not a single term. So I can't just like cancel out the x's and that sort of thing. All right, so I'm going to do the first derivative, and that won't be too bad. But it is going to require the quotient rule. So I do the derivative of the numerator, which would be 2x plus 3, times the denominator as is, minus the derivative of the denominator times the numerator as is, all of that over the denominator squared, okay? So in the numerator, I'm going to FOIL this out, get 2x squared. Let's see, 2x squared minus 8x plus 3x minus 12. Distribute the negative 1 on that second binomial, get minus x squared minus 3x, and all of that's over x minus 4 squared. Normally, we don't ever multiply the denominator out. We just will collect our like terms. So we're going to wind up with an x squared, and then the 3x's cancel, so we'll be left with minus 8x minus 12 on top. Normally, we wouldn't multiply out that denominator, but in 3-3, which is what this goes with, you didn't yet know the chain rule, but typically you would just do the chain rule to do when you get ready to do the second derivative. But you didn't know the chain rule, so I'm going to go ahead and multiply that denominator out to get prepared. And x minus 4 squared, remember, is not just x squared minus 16 or plus 16. You have to FOIL, and you'll get a middle term of negative 8x. Now, the only reason I'm doing that is because I'm going to have to do the second derivative of this, okay? So I'm going to start the second derivative. Let me change colors here. All right, so for the second derivative, what I'm going to do is take the derivative of the top, which would be 2x minus 8, times the denominator as is, oops, that's 16, minus the derivative of the denominator, which is 2x minus 8, times the derivative of the numerator. Times the numerator as is. So let me say that better. So this was the derivative of the top times the bottom minus the derivative of the bottom times the top. And all of that's going to be over the denominator squared, but this is what the denominator really used to be. So let's put that back in, and then we'll square that. Okay. So it'll have a good form. All right. So here you got some options on how you would do this. I'm going to do a video and talk more in class about how to factor out to try to simplify the algebra on this. So notice that 2x minus 8 was common. Good way to do that would be to factor out the 2x minus 8 and see what's left. So if you take out the 2x minus 8 from the first chunk, you'd have x squared minus 8x plus 16. If you take it out of the second chunk, you'll have minus left and the x squared minus 8x minus 12. Now, I didn't do something with that negative yet, so I'm going to do that in a minute. I'm getting distracted. My dog is getting into stuff. Okay. So now at this point, what we're going to do is continue working on that numerator. So do you see how I got a 4 down in the denominator? I did the 2 squared to get the 4. Now what I'm going to do is work on this part right here, this inside the brackets. I'll leave the 2x minus 8 for a minute. Then inside there, I'm going to have x squared minus 8x plus 16. And then that negative I'm going to distribute. So I'll get negative x squared plus 8x plus 12. Okay? And I'm trying not to lose track of where I'm at and what I have. All right. So we basically have it. We just need to work on simplifying. So the x squareds are gone. The 8x and the negative 8x cancel. I wind up with a 2x minus 8. And I also have a 16 plus 12. So that's 28 right there. And then I have this x minus 4 to the 4th power. All right. What I might do is factor out. I might factor out the 2 that's common here and put it with the 48. So the 28, and 28 would be 56. Factoring out a 2 from here, see? And then putting that 2 with that 28, I could leave it in factored form like that. Okay. Or I could leave it multiplied out, which would be 56x minus, what's 4 times that? It's 24, 224 over the x minus 4 to the 4th power. Okay. All right. So, okay. So I think we're okay there. I'm going to go back and check them in case I messed up a sign or something. So let me do that real quick. Okay. So let's go back to the beginning. Make sure we didn't mess up a sign. So the derivative of the top times the bottom minus the derivative of the bottom times the top. So that's negative. And that would be 2x squared. 3x and that would cancel. I would have minus 12 there. Okay, so that looks good. And that looks good. All right. Okay, so this looks good. This looks good. And then here, after I factored out the 2x minus 8, I would distribute, get a negative, positive, positive. So I just have 28 that's positive left. All right. Oh. Gosh, it looks like rather than doing what I did, the only thing I noticed is when I factored out the 2, I had an x minus 4 here. Instead of doing that, I really should have just taken out one of the x minus 4s. That would have been better, and done that. Okay. All right, so let's continue, and let's do a couple with some trig functions in them. So we're doing second derivatives on this chunk of problems. All right, so let's try another one. All right, so on this one, I'm trying to do second derivative. So I do the first derivative, and the derivative of secant is secant x tangent x. Okay, when I go to do the second derivative, I now have a product rule problem. So I'm going to do the derivative of the first, which would be secant x tangent x again. And then I'd have to multiply by the second function as is. So this right here is the derivative of secant. And then I multiply by the second function as is. Then I'm going to add to that the derivative of the second function. And the second function is tangent. Okay, so the derivative of tangent would be secant squared x, and then I multiply by the first function as is. So I have a secant x tangent squared x plus secant to the third x at that point. Okay. All right, there is a secant x that I could pull out of both, and I would have tangent squared x plus secant squared x. But there's no nice, easy identity that would be equal to. So this would be your final answer on that one. Okay. All right, and then let's try 108. I'm going to grab that, copy it, put it down here. Okay, didn't go where I wanted. Sorry. Get it. Put it a little further down. Okay. And let's look at this one. All right. All right, now this one has a E function and a sine function. Okay, and it's a product rule, clearly a product rule problem. All right, so let's see what happens on this one. So we would do the first derivative first. So we would do the derivative of the first function, which would be e to the t, times the second function as is. Then we would do the derivative of the second function, which is cosine t, times the first function as is. And this is not a quotient rule, so that's it. Okay. All right, so at that point, you might notice there's an e to the t that's common. You might think about factoring that out, but you're going to have to do a second derivative of it. So I'm not sure that's necessarily that helpful right now. So I'm going to leave it all like that and just go another round. Let me change to another color. I'm working on the second derivative now. Now, if I were just trying to do the first derivative, I would have pulled out the e to the t and had sine t plus cosine t left. And actually, maybe I'll do that. Maybe I'll do that. Go ahead and factor. Okay, so let me go back to blue. Let's go ahead and do that first. And this is still first derivative. I'm just going to go ahead and do what I just did, but I was trying to decide if it would be easier or not. If I factor out the e to the t, I have sine t plus cosine t. Okay. Now, let me change to another color, and let's start the second derivative. And then here's the product rule. So the derivative of the first times the second function as is, okay, plus the derivative of the second function. And see, that plus means I can do the derivative of each piece. So the derivative of sine is cosine, but the derivative of cosine is negative sine t. So that's the derivative of the second function times the first function as is. Okay. So here's a case where I notice this e to the t is common again. So I'm going to factor it out. What's left from the first chunk is sine t plus cosine t. And then what's left from the second chunk is cosine t minus sine t. So sine t and negative sine t, e to the t, and then there's one of these and another one of these. There's two of them. Okay. And it would look a little better if I put the 2 out in front, maybe. And there you have it. That would be the second derivative. Okay. All right, so what I was doing in this video was looking at how to do second derivative. So when you do the second derivative, you do the first derivative using whatever rule is required, or whatever. You can use a variety of rules depending upon what you prefer. But if it involves, like this one did, a product, then we had to use, I moved it down here, remember? I had to use the product rule. Okay. And then you just do the derivative of the first derivative. That one had to use the quotient rule on this guy because I just had to. There's no way to convert that to avoid the quotient rule. That one was really messy. I'm going to look at that one again after I stop the video, see if there's a better way to clean it up. I move that one right here. So yes. Okay. All right, so I hope that helps. And let me get these